That creates trouble. All right. So nice. So this topic looks disjoint at the first look. How come blockchain is connected? Okay, I take it as okay. Coming to industrial revolution, when we turn back how the industrial revolution happened, uh, we named the versions according to the evolution what we have seen. The, when the industry started flourishing as in the first using the steam power, that's been named as industry version 1.0, where the majority of the activities are done through the steam energy. Later, when it evolved to the next stage, probably they might have not known that we will be evolving to this level in the current state, and we don't know where we will evolve further. I'm sure all we know is we will evolve, but where is decided by the time. So these names probably we have given after a certain time when we turn back the history and what happened in the past. So the next revolution after industry 1.0 is the invention of electricity and the invention of the super device called motor. That created a lot of impact in the industry segment, and that's been named as Industry O. Later, the modern technologies came. Computers started getting into the industrial atmosphere, like a PLC, programmable logic control, which helped the industries to automate many things, and the productivity became really high. That era has been named as Industry 3, which we were living till date. Now we are getting into the next era called Industry 4, where we have network of cyber physical systems, digitize the environment in order to make use of the technology to maximize the performance, leverage the processes, all this. So this word I4, the industry 4, is no more a buzzword. It already started impacting the industry. So here the challenges are, or the interesting part is, every devices device or assert in the industrial environment become intelligent assert. It is connected to the network. It can communicate within each other. Lot of data has been generated, and the data will be used to make some inference. It can use to predict the future. It can make some knowledge over the time, and everything will be finally used to benefit the industry. Yeah. Any query, please stop me. We can have discussion. Okay. If not, I will move on. Let's discuss a little more detail about Industry 4.0, some key aspects. What is a cyber physical system? A cyber physical system, a system which is connected to network, which has capacity to communicate data with the administration or within the devices, and it became smart or intelligent, and it can potentially become fully autonomous or semi-autonomous. Since it generates a lot of data in the environment, we have to handle big chunk of data, and topics related to big data analytics come into picture. And here, multiple parties are involved. For example, if you talk about the manufacturing facility, the manufacturer himself involved in this, and his customers can get involved in this, and the suppliers who supply the raw material or semi-finished goods to them are involved in this. So there are multiple parties involved in it, and a different kind of data is involved. You can't expect the data to be in the same format. So the heterogeneous data set and heterogeneous tools from different OEMs are involved in it. Different platforms are involved in it. Yeah, and there is another interesting topic: digital thread. Digital thread is is connecting this ecosystem. I will be talking a little more detail in the next slide. This is the one which connects this ecosystem so that the data can be transferred hassle-free. Yeah, I will talk a little more about this in the next slide. What are the enabling technologies here? Um, Primarily, the technologies what I can immediately list are here: the artificial intelligence or machine learning, um, data analytics, digital twin and digital thread, cloud and edge computing. Um, you you might be expert in one of these things already, um, but where blockchain is coming into picture here is blockchain being considered as a part of industry 4.0? This is a question I'm putting a question mark, because this topic is coming up. um, we will talk little more on this after completing this exploration on the industry 4.0. Yeah, any queries? All right, if not, we will move on. Let me give some overview about digital thread and for I4. Digital thread, I'm going to read the sentence which I created after referring many definitions. Definition, if we look for definition, there are many definitions, and we might not achieve a common consensus on the definition. It will never happen, because the intellectual community will never agree for one definition. But this is the definition what I saw based on contribution from different directions. Yeah, digital thread refers to a collaborative engineering and communication framework which connects data flow and data views from different models of a part or a system or a system of systems throughout its life cycle, cutting across traditionally siloed functions for from concept to the end of life. In conventional system, if you talk about product development, manufacturing, and sales and service, there are different domains involved in it. The product lifecycle management, for example, design department deals only about design. Once the design is done, they will create the bill of material, which carries what are the parts, how many number, and how it's related to each other, how it should be assembled. And once the design is finalized, you get into production planning, where the team involved in production planning think about how to get this product done in the market so that they can sell in the market. So production planning talks about how to make this component. So what all I need to get to make this product. Like, for example, I give a very simple example. If you want to make Mysore pak, right, a sweet which we all know, which we all love, if you ask for the ingredients, they will say dal powder, ghee, and sugar are the ingredients. So that comes as a bill of material. But when you want to make it, you can't just make with these three ingredients. You need a vessel, you need a stove, you need gas, you need many other things in order to make it, so that you can taste the sweet. So that is called production bill of material. Yeah. So this production bill of material is generally created by the production planning team. They need to define what all the equipments they want to manufacture this, and next comes the actual execution of the production system. They take once the production planning is done, that is implemented, and then the production starts. During production, there are many challenges: how to utilize the devices more optimally, how to make sure the productivity is high, how to keep my throughput high. And then once my production is done, the product is out for the market, and then I go and sell to the market. And in the market, while the product is working, it need to be monitored. It need to be continuously monitored for its health, its utilization, and end of life. Conventionally, these departments work in silos. They don't talk to each other that easily. Even if they want to talk, there are protocols. They need to go through some approval chain and get information to share, and it happens with a lot of pain. Everyone agrees, conventional manufacturing setup, product development setup, that's how it happens. But digital thread is the one which mends this gap. It ties all these departments seamlessly, so that data flows between these departments seamlessly across the value chain. Machine to machine can talk, machine to machine communication can happen, person to machine or machine to person communication happen. And now people prefer open architecture for data exchange so that there is less uh, complexity about the proprietary locks, and they want this to be more scalable, and traceability is an important requirement when we invest our money for establishing this kind of digital thread. It is very obvious that we expect traceability, because that's a key message, what a key advantage what we get out of this. If something happens at some location, what is the root cause? I can go and trace. It could be at the design department, it could be at the production planning, or wherever it is. So that's traceability is the one what is key here when we establish digital thread. And when we have different kind of tools and methods, processes involved, we need to have interoperability. Tools should understand what other tools are talking. For example, if I use Siemens SIM Center tool, there is a format for it. If there is another tool used by the end user, and he expects those tools to talk to each other in order to automate, and they prefer, at least the direction is more fully about having a platform independent infrastructure. And in this scenario, physical asset, digital twins are nothing but digital representation of a physical asset. This again is one more topic. I'm not deep diving into this topic. This digital twins can also get into this network. Physical assets can get in. Software tools can get in. Sensors, nothing but IoT means Internet of Things comes through sensors. The sensorics part is very important, and those sensors need to be connected in the network, and the process. Everything need to be connected in the same framework. That's recommend. Digital thread helps that. And data, if you have a handful of data, then the question is how to use that. You need to make meaningful inference from the data. You need to create information in for that and make a informed and transparent decision. The advantages are this ensures data integrity. There is less chance for fudging the data, and it makes things traceable because it's connecting end to end. And this is really helping something called change management. I would like to give a brief about what is change management. Let's say that in a manufacturing environment, the manufacturer want to release the next version of a product with a small change. He identify a customer pain point, and he want to introduce a change in the product so that he will alleviate that customer pain point. But if he decide to go for a change, he has to address all the requirement to accommodate the change, whether it's design or manufacturing or sales or service, whatever it is. So generally, when there is a change request, it goes with analysis of change impact. What this change will bring to me, what all the impacts I will get. And that analysis is key in order to make the change more appropriate and get the work done with minimal impact on my workflow. This change management is key. It needs information. If you want to do this, you need data from all the domains, and that data is valuable for making this change management effective. And this digital thread also allows reusability. Like I have a model developed in the design stage. How can I reuse that model for my production setup? How can I leverage that? How can I reuse that model in my service setup in order to create a digital twin of the product and track the usability of the device? For example, I'll give again layman example. We buy scooters, right? Let's say we all in this team, let's say 20 scooters we are buying from Vespa. Vespa is launching colorful scooters. I like it. We are getting the same variant of scooter, probably different color, doesn't matter. But we use it differently. Professor Kannan may use it differently. Professor Shivakumar can use it differently. I use it differently, and every one of you use it differently as per your requirement. Though the product is same variant, same manufacturing facility, everything is same, the design points are same, the usage is not same, and hence the maintenance schedule will vary for myself, Professor Shivakumar, Professor Kannan. The requirements will vary. How to understand that? If I have a digital twin of this Vespa scooter, the variant what we considered, then I can flash the digital twin of that scooter in all our devices, all our scooters individually, and so my scooter can have a digital partner, and the digital partner will continuously monitor my asset health, and it can tell, hey, JV, you have to go for a service within a week. You have a risk of failing your engine. Yeah, maybe Kannan is not using the scooter often, so he may get a different schedule. So this digital twins can actually bring in a lot of advantage in reusability part as well. The models can be reused at multiple value chain. Knowledge flow is another key important advantage. The knowledge flows from departments, with seamlessly it flows. And again, I said easy decision making. When you have information, you can take an informed decision, and you can take a calculated risk. That's possible with information. Yeah. Any query here? Please do stop me if you have any query. We can make it interactive.
How economical it could be using a digital twin, uh, manufacturing it and then maintaining it?
Um, that depends on what kind of digital twin we want. For example, digital twin can be high fidelity, low fidelity. Yeah, it can be physics-based digital twin. It can be data-based digital twin. So what option we choose, that decides the economy around that, like how much we need to spend. Uh, Again, when you go to industrial setup, no one will invest in something which will not bring any return on investment. So that's key. The value what we invest is depending on value what we will get out. So that is a function of the requirement, Preeti.
Okay.
Any other question? All right, I'll move on to the next slide. Let me give a brief overview about some of the standards and organizations related to digital thread or the information flow or the Internet of Things. Uh, this is not limited, that there are many, but I'm just listing out something key which you may be interested to know. The Industrial Internet Consortium, they bring together different organizations and technologies to accelerate the growth of the Internet of Things. Their goal is to identify, assemble, test, and promote the best practices to all. Yeah, and the next important one is the OPC, Open Platform Communication Foundation. They call OPC UA, and Unified Architecture. Uh, this talks for interoperability standards, and this is a key standard. Even many of the hardware manufacturers are following this. Why I'm telling all this is when you want to connect blockchain to IoT, we have to understand the standards as well. Then only it makes sense, right? The third one is Object Management Group, OMG, shortly they call. It's an international open membership technologies standards consortium. And functional mockup interface, FMI or FMU, a functional mockup unit, it's a free standard. It helps to make different OEMs to collaborate, and the tools created by different OEMs can talk to each other through a FMU or FMI. Yeah, National Institute of Standards and Technology also play a key role here. So you can keep this in mind when you're planning to work on these topics in future. This may be helpful to you. Yeah. Now let us get into the next topic. So we have talked about the bridegroom. Now we are talking about the bride. Yeah. Uh, Finally, we will talk about the marriage. So blockchain distributed ledger. Blockchain you might be knowing already, because blockchain topic it has been a buzzword for a long time, but now this topic is getting into mainstream. We could see many industries started investing significantly in this topic in order to make some enterprise solution. Just in case if someone would like to get a basic, this is nothing but block of data connected to each other, which timestamp using a technique called hashing. Basically, any block of data is connected to the past data and the future data by a technique called hashing. The hashing, there could be different techniques. One of the thing what I show here is the secured hashing algorithm 256. The beauty, I like this really because you give any input, it converts into a key of 256 characters, and even a small change in the input. Let's say if I put I instead of capital, if I put small, then this key totally looks different, and you can't reverse calculate. Till now, at least, I have not seen a case where people could reverse calculate based on the hash what is the input. So that's the beauty of this technology. This is one of the key technology which made blockchain more successful. And other topic which made blockchain successful is the cryptography. It offers four major things. One is confidentiality. This blockchain is a network where many participants are there, but still, if a data need to be transferred from one participant to other, the confidentiality is maintained. Only the end user who is intended for the data can open that. And integrity means the data cannot be modified in between. And non-repudiation. No one can say that, no, I'm not. It's not me. They can't say like that because it's well connected. Anyone can understand who has sent the data, who has received it, whether it intended for them or not, whether it's really from that person who want to send the data to you. And authentication. Yeah, authentication is the one what I lastly explained. It makes sure that the sender and the receivers are authentic, through asymmetric cryptography. Yeah. So that's blockchain. There are few key important parameters which made this blockchain technology very successful, at least from the industrial point of view. The immutable nature, the distributed nature, and the transparent nature are potential three top list. I would say maybe people may differ in this, but I see these three parameters as top three in order to make it very useful for industrial ecosystem. But industry not always expect things to be 100% transparent because they want to maintain the competitive edge. They can't lose the competitive edge because of the part transparent. So that's where the enterprise blockchain networks started popping up to cater this need. It can be customized as required by the industries. The transparency need to be maintained where it is expected to be maintained. There are some parameters which need to be kept confidential, like the price data or the supplier information, so that they can maintain their the competitive advantage. And immutability is very important because they want the data to be unfudgeable, so that there is no need for an audit. This process makes sure that the data is immutable, unfudgeable, so there is no need for an audit. All we need to do is a check, like what is the state of the parameter. That's what we can do. Any question here? I think most of you might be aware about this slide, but I'm just, for a sake of continuity, I'm showing this to you. Yeah, now let me go to the enterprise blockchain network. There are a handful of opportunities available. For example, Hyperledger Fabric, owned by the Linux Foundation and open source ecosystem, is very popular now. It's showing promising results. The other one is Corda, that is also an open source. And the Quorum is another blockchain network. VChain is mainly designed for supply chain requirements. This could be a Chinese company, I guess. I'm not sure, but this is focusing on supply chain. It ensures the safety of the food product being supplied from one point to another point. And everyone knows Ethereum open blockchain network. This is primarily used for cryptocurrency. And IBM is also creating a platform basically on or over and above the Hyperledger Fabric based network. IBM is offering the platform not for open source, it's chargeable. Yeah. Let's get into a comparison. What I noticed in the open source, I'm seeing a quick comparison. There are 6 parameters we need to check primarily for these kind of this blockchain networks. One is whether it's open source or closed source. Most of them are open source except IBM and VeChain. I don't know. I have to still explore that. So I did not populate that. And private or public, except Ethereum, all other things are private blockchain. So that's what industrial network needs. Industrial network don't need a public network because of common difficulties. Like they don't want to share the information with everyone in the network. They want to share only with the intended parties or interested people. So permissioned or permissionless, VeChain looks to be both. That's what I saw, but I'm yet to explore completely. But otherwise, all other options here are permissioned except Ethereum. Ethereum is permissionless; anyone can join. Scalability, most of them looks very high. VeChain has been mentioned as low by one of the articles. Ethereum may not be very scalable in my view, but I don't know the current status if someone invented a method to make it very scalable. But performance-wise, all these permissioned private networks are high in this slide. And security also, except Ethereum, all other things are seems to be high. Any queries here? All right. So I would like to share one of the article published by Deloitte. They published this article end of first quarter last year. I think March. It's 1 year now, I would say, but still this data to an extent makes sense. I don't know how well this was achieved by industries, but this data makes some sense. If you see, 40% of 40% of the companies are investing in blockchain. Means at that point of coming here, that means already it is done. So I don't know whether 40%, but I'm sure these numbers are making sense. Almost all the major corporates are investing in blockchain technology. Almost all the corporates are building teams for blockchain technology. That is true. The three the important use cases what they mentioned in that report is one is data validation, data access and sharing, and identity protection. These three are the top three use cases they have mentioned, and there are many other interesting stuff in this article. Please, you can go through that. I have given the link for that. Here they have compared a few of the available blockchain networks with the two axes. One is public or private, other is permissioned or permissionless. So obviously in the industrial network, we want private permissioned. That's what required. And in that, I'm seeing Hyperledger Fabric, Coda, and even the quorum is also listed here. Yeah. And they have given a comparison based on three important aspects. One is security, other is scalability, and distribution, decentralization. They compared three such networks called Coda, Ethereum, and VeChain. And generally, it appears that every product is lagging in one of the aspects and gaining edge on other two. Yeah, if you see the blue and green, Coda and VeChain are almost same, whereas Ethereum is slightly lagging in the security compared to these two. Yeah, these informations are available open source. Please do use that. So now coming to the marriage part, these two technologies, the blockchain technology is not new. It is not new definitely. But when Nakamoto proposed this for bitcoins, the concept became popular. Uh, for the cryptocurrency, and then people started talking about it, but now this is getting into the mainstream. Industry 4.0, again, it's a separate topic where we want to utilize all the technologies in order to make the industrial environment more productive, more efficient, less costly, and blah blah blah, I can tell many. So these two, now they are meeting each other. How can I use blockchain to enable industry 4.0? The strengths of blockchain very suitable for digital thread. Digital threads objective is to data flow, traceability, avoid the risk of centralized storage, immutable. All these are guaranteed by blockchain. Yeah, blockchain digital thread. I have worked on three topics. One is blockchain digital thread for root cause analysis in production environment and for prediction as well. So, when you have a production environment, you have a lot of asserts in it, and every assert do transactions. It adds value, and each value addition has been considered as a transaction. If we could log all this data into a blockchain network, what I did was I used an open source Ethereum blockchain network. We used this Robston test network in order to try this out. Of course, that's not the best way to do, but we did it because that's a easily available thing. With less effort, we can try it. So this data of every activity in the industrial network has been pumped into the Robson test network, and we have a Python-based block explorer in order to trace the activities and connection between these processes. For example, if I get a defective product in my production network, I can understand what is the root cause of the defect by comparing that product and its related activities in the industrial environment with a quality product, a product without any quality issue. If I compare this, my blockchain explorer can pull in all the information related to these products, and it can tell what is really differing between these two products, and I can identify what could be the potential root cause. So this we have tried out, and this topic is very suitable for audit requirements. For example, audit, we do two scenarios. One is internal audit. I want to improve my processes. I have to keep up to the date so that I can reach my targets. That's an internal audit. I don't need to answer external party, but I need to answer myself. My own audit team will come and audit me, and they will ensure whether all the accepted protocols are adhered or not. If it is adherence is ensured, they will give a clean sheet. If it is slipped somewhere, they will give a sheet mentioning there is a slippage. So there is another audit for external party. For example, if I have an ISO certificate, an ISO agent can come and audit my facility to understand whether I'm adhering to my commitments or not. So there, in both scenarios, the reliability of the data being produced before the auditing community make a lot of impact. The majority of the effort for the auditing team, it goes in going and verifying whether the data supplied is correct or not. For example, if audit team comes to me, they ask, what is the requirement for this project? I will list out what are the requirements. Then they will check from where you got these requirements. Can you show me where this requirement comes from? Then I need to show the discussions, what I did in order to gain to collect these requirements with my customer. I need to show the proof points. I need to show the minutes of the meeting so that these requirements are properly connected as per my agreement with ISO, and they will evaluate this. But this is, in my view, is a redundant activity because this is happening. We don't have trust on the data given by given to the auditor, right? When you deploy blockchain, that question is eliminated. The data given in the blockchain is ensured. So all you need to do is you need to just check whether the parameter is adhering to the protocol or not. If it is adhering, you are continuing the certification. If not, you need to rework. Yeah, so it's that simple. So there is no need for a audit process with specific frequency. Auditing can be a continuous process. That's doable. And we have tried out something around this using some inbuilt Python codes. And the next thing is trust for collaboration between multiple parties when it comes to industrial environment. I have an, let's say I have an industry, my supplier gives sub-assemblies for me. Before I give this order to them, I go and do an audit. I go and check whether the supplier is qualified to produce the components for me or not. I give my requirement. I check whether they have the capacity to adhere to that or not. If they are eligible, order will be given, but there will be a continuous check, or there will be a frequent check on my supplier in order to check whether they are adhering to that or not. But from my supply point of view, let's say that if I am massive in the size, then supplier will be mostly adhering to the data what I supply, because I own the data. I have superiority on deciding what data I should supply to him because they are dependent. So this creates little imbalance between multiple parties involved in the collaboration. If we this digital thread, blockchain digital thread, if it is implemented, it can actually give a balanced importance to anyone in the market. For example, a supplier, even if it is small, he will own his data, and the OEM who is getting components from him, he will own his data, and he can't go and fudge the data. So data trust is ensured, and I can also modify, I can also monitor what is the parameter variation in my supplier side. What are the variations I can observe in their process that can be monitored continuously. So this can help people to come together and make a win-win situation. So blockchain is a solution for digital thread and hence for I4. Coming to the challenges, we have a handful of platforms, open blockchain network, but which one I should select? That's a $1 million question. Today, Hyperledger Fabric may look beautiful to me. I may go and invest my energy to create a Hyperledger-based platform. But tomorrow, let's say, if something else pops up and it becomes successful more than Hyperledger Fabric, what should I do? How long my process will live? The longevity, that's a big question. And what are the standards I need to follow? I should not miss out some standards so that I will not be behind the scene. So I will make sure that I will gain from the process what I established, what I invested. And if I want to increase my scalability, if I want to increase my production facility, if I want to double it, is it scalable? Or do I need to reinvent the wheel again from the scratch in order to include that new facility? So these are the questions which we need to answer to choose the right blockchain network. The interface with heterogeneous environment is again a major challenge. So these are all my views about the challenges what we can potentially face when we want to get into blockchain network, enterprise blockchain network. Yeah. Is there any query? Please do ask me. I can share my best. All right, then I will go to two examples which can explain. There are other examples, but still I'm seeing the blockchain-based solutions are still coming up. Really, still coming up. It's not to the. It is not to the place where it was expected to be till now, but now it's gaining a momentum. The first example I would like to give is Go Direct by Honeywell. They are giving this portal which is supported by a blockchain background. It is very much applicable for aerospace industry when aircraft see end of life, that the aircraft will be disassembled and all the useful parts in it still carries value, and hence that can be sold out to the market which can use those spares with remaining useful life being marked on it as per the audit. But it needs a lot of paperwork. because when they disassemble, the risks are a non-authentic part can be pumped in as in the name of authentic part, and the evaluation about the remaining useful life can be fudged, and ability to reach out to the right customer is again a challenge. So this makes this market expensive. Aircraft industry already expensive, and the spare cost can still shoot up. When someone is ready to put a used cost, the used component in aircraft industry still carry a lot of value, unlike an automobile industry. So still it makes the cost higher because of these difficulties. And this solution probably could help the users in order to gain confidence on the paperwork. I mean, there is no need for paperwork like a conventional method. The blockchain can connect the spares right from the day it was disassembled from the decommissioned aircraft, and where it is stored, where it is available. All those details can be tracked and it's stored in the blockchain. So the reliability is very high for the user who want to purchase this. Another solution is recently I saw in an IBM digital health pass. The COVID situation, we are working from home. I'm working from home for last 1 year, and now we are planning to return to office. Now the question is, am I safe? Because it's connected to my family, my friends, and my colleagues. Everyone's health is very important, and how to ensure that we are working safe in the office space when we go back to work. So the post-COVID scenario pushes many people to work towards solutions, particularly mobile-based solutions, in order to manage this. And IBM has launched, IBM Watson has launched a digital health pass. It's an app which can track individual health records without compromising on the privacy part. This looks one more example using the blockchain, and that's why I just shared it here. Yeah, so that's all I have. Thank you very much for listening to me. Now, I would appreciate if you have any queries, questions. If I could answer, I will share. If not, I can provide answer after giving a search to it. Thank you.